Welcome back all of you. So, in the last lecture we have seen a few aspects related to pore water pressure and its estimation. Next we will move on to shear strength determination with specific focus on triaxial testing. Many of you would have already studied triaxial testing properly during your undergraduate. So, please take this as a revision of triaxial test, because in the subsequent lectures we will rely a lot on triaxial test and its interpretation, which is mandatory for understanding stress path and critical state soil mechanics. So, I cannot forego this topic even though it is taught in UG, and in addition we will be discussing a few additional points which is actually needed for this particular course. So, we will have a brief on what triaxial test is and what are its possibilities, and then in the subsequent lecture we will see its interpretation. Okay. So, this is all about triaxial test. So, triaxial test is the most versatile shear strength test for soils due to control of drainage condition and pore water pressure measurement. Now, in the field you have different possibilities. A low permeable soil has the drainage capacity quite low, which means to say when a load is acted upon on a low permeable soil, you are likely to have undrained condition for substantial amount of time. Similarly, there will be development of pore water pressure. So, there will be undrained condition pore water pressure. With time, pore water pressure dissipation happens, and at very large time what happens is a pure completely drained condition would exist. So, we have the strength of the soil at its short term, that is undrained condition, what will be its strength, and for a long term what will be its strength. Now, it is very difficult to define something called undrained shear strength, because we know that based on effective stress principle the strength is entirely dependent on effective stress condition. However, soil will be possessing some amount of effective stress even under undrained condition, and that is why we need to have the idea of pore water pressure. And most of the effective stress condition which is relevant for the soil, it is there right at the beginning, which is mostly associated with its initial state from where the soil has been sampled. So, for simulating different conditions, the most versatile test that we have is triaxial test. So, we will see quickly what a triaxial test apparatus looks like, because that is needed to understand this particular aspect, how it becomes versatile. So, this is the soil sample which is mounted in the triaxial cell, and on top of it you have porous disc which permits drainage of water from soil outwards when the loading happens. Okay. And there are two caps, one is the bottom cap and the top cap, for delegating the load equally to the soil. Now, we have the provision for applying cell pressure, then there is a provision for recording pore water. Now by this time I hope all of you are familiar with U, If I write only U, it means pore water pressure. So, pore water pressure can be measured, and there are provision for drainage of the soil sample, and there is a provision for back pressure, which is more or less in together with drainage condition. So, we have different outlets. Then the soil is housed inside a membrane, so that the soil is not able to interact with the water outside, because cell pressure is delegated, there will be water within this chamber. This is the ram through which the axial load is delegated to the sample, and there is an air bleed valve in order to allow the air to escape from this water. So, when you fill this chamber with water for applying cell pressure, any entrapped air bubbles or dissolved air bubbles is forced further out through this air bleed valve. So, this is the overall setup of triaxial test. So, when the stress is applied or when the load is applied onto the soil sample, this is how it looks like. So, it is the total stress acting on triaxial sample. The first is the confinement that you give, sigma 3, and then is the axial load which comes from here. So, that is denoted as sigma 1. Now, in triaxial testing, it is important to understand what causes failure. So, initially there was a confining stress sigma 3 all round. This stress will not partake in the process of failure, because this is an isotropic stress condition, the mean stress condition where all round stresses are equal. Now, this creates volume change, but not shear stress within the soil. This we have already discussed. Then what causes failure? So, when you apply the load, that is the ram, this load which is delegated to the axial this system, so that causes failure, that induces shear within the soil. This also we have discussed before. But what is exactly that is causing failure? That is the deviatoric stress component which induces shear, and that causes failure. That is given by this. So, the total stress, which is the axial stress as well plus the confining stress which is acting on the top of the sample, that is together the major principal stress. Hence, the deviatoric stress is nothing but sigma 1 minus sigma 3. So, this is further explained here. Sigma 1 is equal to sigma 3 plus the force which is applied through axial force, that is applied through this ram, divided by area of cross section of the sample. So, sigma 1 is equal to sigma 3 plus sigma d, hence sigma d is equal to sigma 1 minus sigma 3. So, F is the axial load applied through loading arm that causes failure. So, area of cross section of soil sample, and sigma 1 is the major principal stress, sigma 3 is the minor principal stress, and sigma d is the deviatoric stress. Now, what are the different tests performed in conventional triaxial compression test setup? Now, why I am using this term conventional means I am talking about the basic triaxial test equipment. Nowadays, there are different variants of triaxial testing possible. You have cyclic triaxial testing, you have unsaturated soil triaxial testing, there are stress path triaxial testing. So, there are different provisions which got added up for specific situations, but I am talking about the very basic triaxial compression test. So, these are the three possible tests which one can do in triaxial compression testing, which is unconsolidated undrained denoted by UU, consolidated undrained CU, and consolidated drained CD. Now, all the information are there in the name itself. So, there are two stages essentially with respect to loading. First is the initial consolidation phase, which is acted upon by cell pressure. So, initial consolidation under cell pressure, and there is drainage, and whether there is loading stage or shearing stage. Now, whether there is initial consolidation under cell pressure, for UU test no, and whether drainage happens under loading. Loading means both cell pressure as well as the axial stress or the deviatoric stress. So, there is no drainage which is happening. So, as it is mounted, it may be saturated and then the load is applied without any drainage and consolidation. So, consolidated undrained CU, there is initial consolidation, which means that there is some changes that is happening to this soil sample during the consolidation phase. That is, confinement is applied and then the drainage valve is opened so that water moves out and consolidation can happen. Whereas, in the case of loading, that is in the shearing stage, it is not. The drainage valve is closed and hence it is a complete undrained condition. Then consolidation also happens, that is drainage valve is not closed. During confinement also it is open and during shearing also it is open, and hence there is volume change which is happening during both the stages. Now, accordingly, the first test is very quick because nothing you have to do, you have to mount the sample, saturate and then load it, and hence the failure happens relatively faster. CU, it is relatively slow, whereas CD is extremely slow. Why this is quick, relatively slow and slow, we will come to know a bit later as we discuss these tests. So, conventional triaxial tests are only applicable for saturated soil. Now, this aspect one need to understand very carefully. Some undergraduate students, they do not appreciate this fact properly, but we need to understand that for conventional triaxial test is only applicable for saturated soil alone. The three important stages in triaxial testing. The first one is the saturation stage. We need to ascertain that the soil samples are fully saturated. If the samples are not fully saturated, we need to perform the saturation. So, the first aspect is we draw the sample from the field for determination of shear strength, and mostly these samples will be undrained. Now, we cannot guarantee that the particular soil sample that we get from the field is saturated. So, first we will check whether the soil is saturated. If it is not, then the first stage is to execute or to induce saturation in the soil sample. Then comes the confining stage or the consolidation stage, and finally the loading or the shearing stage. So, these are the three important stages in triaxial testing. So, let us see the features of unconsolidated undrained test. We are not going to discuss any results in this lecture. We will understand clearly what are the possibilities of these tests. No drainage and consolidation during confining and loading stage, we have seen this. Now, pore water pressure measurement is not useful. This is an undrained test. What else is going to happen other than pore water pressure? But still, one can always measure the pore water pressure in UU test, but that is not going to be useful. Why? We will see this when we discuss about the results of UU test. Primarily, a total stress analysis required for determining undrained shear strength. Okay, so, this is purely a total stress analysis, and the second statement and third statement, they are complementary to each other, because if there is no pore water pressure measurement use, if the pore water pressure measurement is not going to be useful, then it is apparent that we are not going to have the results in terms of effective stress. So, it is a total stress analysis and only useful for undrained shear strength. Confining pressure is applied and the specimen is sheared. There is no waiting period because consolidation is not there. Rate of loading is fast and results in quick failure. No volume change test. So, this is specifically a no volume change test if the soil is fully saturated. So, these minute points one need to keep in mind. Why should I write if soil is fully saturated? A clue you will get when because if you have gone through the lectures of pore water pressure, what is the effect of partial saturation on B parameter? So, same thing is applicable here. If there are air present in the sample, then air will get displaced in the process. So, what is going to happen is, if it is fully saturated, whatever is the initial effective stress, that remains same. But if you allow any sort of volume change, and that will alter the initial effective stress, and once it is altered, the strength also gets affected. So, that is the reason. So, it is understood that there is no volume change which takes place. So, the stage 1 is saturation, the stage 2 is confinement. So, we have the pore water pressure which is developed, which is corresponding to the confinement sigma 3. You may choose to measure or you may choose not to measure, it is not mandatory, but you see, even if it is measured, is not going to be useful in this test. So, the loading stage is you are applying the deviatoric load through the axial provision which is there in the triaxial testing, and hence the cumulative pore water pressure at the failure is UF. So, this is how it is. Next we will see consolidated undrained test. So, we have drainage allowed during confinement stage resulting in isotropic consolidation. Yes, we need to note here that the consolidation happens under isotropic condition. After consolidation stage, U is equal to 0 or U is equal to back pressure. Please hold on for some time, we will discuss at length what is meant by back pressure. Ideally, during consolidation, the drainage valve is kept open. So, there will be no development of pore water pressure. Hence, at the end of consolidation stage, pore water pressure will be 0 provided the drainage line is kept open to atmospheric pressure. Now, there is some arrangement for applying back pressure which we will see soon, and if it is so, then at the end of consolidation stage, this particular pore water pressure in terms of back pressure do exist. These are again some minor points, but very important points you need to keep in mind for appreciating or understanding the development of pore water pressure, how you determine the effective stress. All these things are dependent on your understanding on what is pore water pressure, what is back pressure, how it is applied. So, these things becomes important. So, please pay specific attention on these points even though it may look very minor. So, after consolidation, the drainage valve is closed, axial load is increased and pore water pressure is measured till failure. Now, you can see here in CU test, it is invariably necessary to obtain the pore water pressure. Only if you know the pore water pressure, you can give the shear strength, or you can represent the stress strain in terms of effective stress. And here it is extremely important that we need to have the effective stress strength parameters, because that is more relevant. Now, due to end restraints of loading cap, we have already seen in the initial figure there are two loading caps, top and bottom, and hence during the undrained loading, pore water pressure generated may not be uniform within the soil sample. Just to avoid this non-uniformity, it is always ideal to have loading at a slower rate. Now, you will appreciate why this particular test is relatively slow than UU test. This is mainly because that the loading rate has to be slow, so that the pore water pressure development, there is a height applicable for this sample. It is not like a consolidation sample, there is an appreciable height. So, when the load is delegated, it may not instantly equilibrate, the pore water pressure may not instantly equilibrate. So, there will be a certain time lag, that is what is known as U may not be uniform, and after keeping for some time it will achieve a uniform value. It is a hydrostatic stress, so it has to be equalized. So, stage 1 is saturation, same as before. Stage 2 consolidation, there is confinement and isotropic consolidation. So, it is a drained stage. Then the drainage valve is closed and the loading stage happens, is the same as before, but there will be development of pore water pressure, that is UF during the undrained stage, and this UF need to be known. As I told in the beginning, we will discuss a bit on what is back pressure in triaxial testing, and this back pressure is applicable for all the 3 testing, because back pressure is useful for saturation, and saturation is mandatory for all the 3 types of tests, all the 3 types of triaxial testing. Now, what is back pressure? It is the water pressure applied to the soil pore water. So, this pressure goes within the soil sample to force the air present in the voids, if any. So, if it is fully saturated, then most of the air voids will be full with water, but in case it is not, then it is the water pressure which will help the air bubbles which are present in the voids to dissolve in the water. Already there is water in the pores, so the air is displaced from the voids and it dissolves in the water, and in the process some minor amount of water gets in and fill the pores. Please make a note, this process is without changing the effective stress condition or the initial state of the sample. Only what is happening is the air which is present dissolves into the water and will get displaced by water. So, water displaces the air and hence it achieves complete saturation, which is a condition mandatory before consolidation or loading. Application of back pressure is needed to facilitate full saturation, and saturation should be ensured. So, it is the raising of pore water pressure without altering the initial effective stress condition of the soil. This is very important. The moment it changes the effective stress, then it is going to have its effect on strength. Now, you will probably understand the importance of discussing pore water pressure. Now, just before discussing this, the lectures we had on pore water pressure, we discussed about A and B parameter. There, when we discussed, we specifically told that B parameter is used for assessing soil saturation. So, that application will come here. So, if B parameter is less than 1, so you check the B parameter. What you do for checking the B parameter? You need to increase the cell pressure by some amount, that is not substantially, some small increment of cell pressure you give and measure the pore water pressure. And B is, we know that it is delta U by delta sigma 3, that is during the confinement. So, measure both. If it is substantial value, then if it is much less than 1, it indicates that it is not saturated. If it is close to 1, it indicates it is saturated. So, both the cell pressure, if the B parameter is much less than 1, which means that it is not saturated, then both the cell pressure and the back pressure is increased in equal increments. Now, back pressure is mostly along with the drainage line from where the pressure is delegated into the soil sample, and that raises the pressure. Now, if cell pressure is not raised simultaneously, there will be a kind of blowing out effect, and that will destabilize the soil sample. Always we have to keep in mind that back pressure application should not be substantial. It also has to be done in small incremental stages. Okay, so if B parameter is less than 1, both cell pressure and back pressure is increased in equal increments. So, B is equal to delta U by delta sigma 3, and we need to keep in mind that always the cell pressure is kept more than back pressure, else there will be case of negative condition. So, always the cell pressure is greater than back pressure. So, the procedure for back pressure application will not alter the initial effective stress condition of the soil. If the initial effective stress condition is affected, this will influence the strength determination of the soil. So, this is the condition when the confinement is applied. So, the initial effective stress condition is sigma 3 I dash is equal to sigma 3 minus u. So, this is the initial condition of the soil. Now, we will make assessment of B parameter. Let us say it is substantially less than 1. So, you need to saturate the sample, this much is understood. So, you apply the back pressure. So, when you apply the back pressure, that is in terms of delta U, that is increase, there is an increase in cell pressure delta sigma 3, and delta sigma 3 is equal to delta U. So, it is equal increment. So, back pressure is increased by delta U. So, the cell pressure is also increased by delta sigma 3, so that the effectively the condition remains the same. So, delta sigma 3 is equal to delta U. So, what is the effective stress condition for this back pressure application is sigma 3 dash back pressure is equal to sigma 3 plus delta sigma 3 minus U plus delta U, that gives sigma 3 minus U. You can see that the sigma 3 minus U and the sigma 3 minus U, and hence there is no alteration in the initial effective stress condition. So, sigma 3 dash back pressure is equal to sigma 3 dash I. So, uses of back pressure: once the back pressure is applied, the saturation will not happen instantly. This also we need to understand. When a load is acted upon into the soil, we say that immediately the water captures all the load. Yes, this is true, but there is a bit of time lag by the time it delegates to the entire soil sample. So, that the back pressure is applied, the saturation will not happen instantly, it is not an instant response. Just because of this, each increment should be small enough and equilibrium time should be long enough. So, we need to wait for some time and the increment has to be small. Let us say that ultimately the back pressure application is around 200 kilopascal. So, always start with a small increment, let us say 50 kilopascal, and then wait for some time till it equilibrate. How do you know it will equilibrate? You keep measuring the pour water pressure, it becomes constant. So, that indicates that the pour water pressure has almost equilibrated. If it is still rising, we have to wait for some time. So, this is what we need to keep in mind. Back pressure application is in small increments, and that small increment has to be kept for sufficient time, and that is known as the equilibrium time. So, equilibrium time permits air displacement and water saturation. The change in pour water pressure after the application of back pressure need to be monitored till it reaches the constant value. The B parameter need to be checked at the end of equilibration time. So, once the pour water pressure equilibrate, we know what is the incremental pour water pressure that has happened for an incremental rise in cell pressure or the back pressure. So, back pressure application and cell pressure application simultaneously, we will measure delta U and delta sigma 3, check the B value. If B value is not satisfactory, normally it is, as a rule of thumb, it is considered as 0.95. So, anything above 0.95 you can treat it to be saturated, but if it is less than 0.95, it is an indication that the saturation has to be made. The process of back pressure increment is repeated. So, with 50 kilopascal it is not getting saturated, another 50 is added. So, total back pressure now becomes 100 kilopascal. Simultaneously the cell pressure is also increased. So, this process goes on, the monitoring goes on, the whole of the saturation process goes in an incremental manner till the B value achieved is around more than 0.95. So, the back pressure is maintained throughout the test and may not be released once the saturation is achieved. So, this is another important point, like once the back pressure is applied, So, it is kept as it is. Once the B value is achieved, it is not that we close it. So, this back pressure would remain, or it may remain in the soil sample till the test is completed. So, back pressure is more like a static pore water pressure. We have seen what is a static pore water pressure. Only the excess pore water pressure brings about changes or volume change in the soil mass or densification in the soil mass. This we have seen. So, here back pressure will not change any such changes, will not bring about any such changes. So, it is more like a static pore water pressure. So, in case of back pressure application, U at the end of consolidation stage will be U of back pressure, that is there will be some amount of pressure already existing in the sample. If back pressure is not applied for saturation, then U at the end of consolidation stage will be 0. Stage 2 is the consolidation stage. After saturation stage, the cell pressure is increased to the required confinement value, which is already pre-decided by the person who is conducting the test. The drainage valve is opened for consolidation to happen. Now, none of this was relevant in UU test. So, we will possibly understand why this test is taking lot of time. Consolidation is also not an instant response, it takes time. So, for under a given pre-decided confining stress, the consolidation is carried out, and for that drainage valve is opened. During consolidation, volume change is measured as a function of time. Volume change is equal to volume of water expelled out of the soil for fully saturated soil. Again, now you will understand why soil has to be fully saturated. Whatever volume change that happens during consolidation, we need to capture that, and for capturing that, it is mandatory that the whole of the soil is fully saturated. So, whatever is the volume of water that gets expelled out, that itself is equal to the volume change that is happening during consolidation. The volume of water flowing out of the soil is recorded and plotted as a function of time, as like given here. So, this is volume of water expelled and this is the time. You can see that initially there is an increase in volume of water expelled and it slowly becomes constant for that particular amount of confinement which is applied. So, once it becomes constant, we understand that the consolidation phase got completed. The plot is used to verify whether the consolidation phase is complete. So, if the soil sample is not fully saturated, then this plot will not represent the actual volume change during consolidation phase. Why? Because the volume change occurring due to expulsion of air cannot be recorded. Now, let us say that there is some amount of air also present because of poor saturation. Now, what will happen when the load is applied, when the confinement load is applied for conducting the consolidation, the air also displaces and there will be a volume change associated with the displacement of air. That volume change we cannot capture. We can capture only from the volume of water which is getting expelled out, which means to say that whatever has been represented by this curve is not complete if the soil is not fully saturated. The volume of air we cannot measure. So, that is the reason it is important that we need to have complete saturation, and this particular curve is very important to decide upon the shearing stage, like when it comes next. So, especially that will become important for drained shearing. So, this particular information becomes important. So, next is the shearing stage of CU test, where drainage valve is closed before the application of axial load, and then axial load is increased, which is the deviatoric load. U measurement is mandatory. We have seen there will be end restraints due to loading cap. Whatever this particular aspect we have already discussed. U may not be uniform throughout the soil sample. To avoid non-uniformity of U loading should be at a slower rate. So, that is about CU test, and next is CD test. Now, CD test is very much similar to that of CU test, everything remains the same, only thing is the drained loading happens. Saturation and confining stage is same as that of CU test, essential that soil is saturated, this is all same. volume of water expelled with time during consolidation state is important, that information is important. Volume change data is used to estimate the rate of loading for shearing stage, that is the loading stage. All results are in terms of effective stress because there is no development of pore water pressure during this test. Now, this also induces the time required for conducting this test. Why? Because rate of shearing should be low such that pore water pressure is not developed throughout the test. We have already seen in the previous lectures that if the rate of loading is higher, then also there can be pore water pressure even though the permeability of the sample is more. Here we need to ensure that there is no pore water pressure that gets generated during loading. Hence, the shearing rate should be low, so that it does not allow any pore water pressure to develop. So, this makes the CD test extremely slow. CD test is suitable for freely draining soil so that U is not developed, especially for sandy type of soils where generally CD test is conducted. So, that is all about the different types of tests that is conducted in triaxial. Those who understand these tests properly, you can think of skipping this lecture, but what are the different possibilities, and during interpretation of triaxial testing we should know what are the different provisions of these tests. So, that is why this lecture is important. So, triaxial tests can be used to simulate different drainage and pore pressure condition, thereby simulating realistic condition in the field. In general, there are three types of triaxial test: UU, CU and CD. There are three stages that is required in the triaxial testing, which is the saturation, confinement and loading or shearing. Full saturation of the soil sample need to be ensured before consolidation and shearing stage. B parameter is used to assess saturation, and practically B greater than 0.95 represents saturation. Back pressure is used to increase saturation of the soil sample in case it is found it is not fully saturated. U measurement is not required in UU test, whereas it is mandatory in CU test. The volume of water expelled with time during consolidation stage can be used to decide the rate of shearing in shearing stage. This will prevent the development of U during shearing in CD test. So, that is all about the discussion on different tests that we can conduct in triaxial testing. Next lecture onwards we will see the interpretation of different types of these tests which we have discussed today, and that interpretation is extremely important because from what test what shear strength you get is extremely important, and the results will be used further when we discuss module 3 and module 4. So, that is all for now. Thank you.